Sorted.
Thank you.
And
And Martin as well.
Yeah, it's a double
Do you want
nap.
to share your screen?
Martin sharing the screen.
Okay. Okay, I'll make the introduction so we can see. You want to go full screen mode?
Okay, hopefully you can all see that.
Yeah, yes, we can. I'll just do an introduction. So our final talk today is a joint talk from Catherine Gall and Martin Green. And they're going to speak about why private 5G networks are a crucial component of your AI system. They're both from Cellnex, and Catherine has worked around telecoms and technology from the 1990s in the USA and UK, including startups focused around cloud services for mobile internet interworking and positions at Cable and Wireless and BT. And Martin is an accomplished sales and marketing leader with extensive experience and market knowledge of industrial automation, energy, automotive, oil and gas, and telecommunication sectors. So we'll hand over to you now, Martin and Catherine. Thank you.
Thank you.
Great. Thank you so much. And thank you for joining us. I wanted to say Tiago's presentation was a perfect complement to the presentation that we're giving today. So before we start, I wanted to tell you a little bit about Cellnex. We get that out of the way. So Cellnex is an enormous company that no one's ever heard of. It's about a 36 billion euro company based in Barcelona. We essentially are the largest tower provider in Europe with over 128,000 sites. So our sites touch over 200 million mobile connected people, and most of our customers are MNOs there, but not exclusively. We bought a company about a year ago called EdgeCom based in Finland. And between Cellnex and the work that EdgeCom had done in the past, we believe we're the largest single provider of private networks in Europe with over 36 private networks and growing every week. So we go to the next slide, please.
So when Catherine and I were sort of speaking about this, we thought we'd sort of go back a step actually and look at some of the challenges, because when you look at what you're trying to do here with AI, the essential component is actually the data, the source of the data and the information. And all too often there's an assumption that the data is readily available. And of course, when you consider where that data is, if it's on a handset and you've got an algorithm either on the handset or in the cloud, then you could argue that your voice and video data and other elements are available from the handset. But if you look in industry and look at enterprise, where that data is, it's not always that straightforward. So the environments can be challenging. The availability of information can be another challenge. A lot of this data is stranded. So how do you get the data in the first place? And of course, there are various means. If we go back 40 years, the only way to get it was actually with a physical connection. Everything was hardwired, and then as time's progressed, technologies have emerged which are wireless, and you're familiar with some of the terms on the screen. We just heard Tiago talk about Wi-Fi. There was mention of Bluetooth, and of course we also have cellular technology such as 4G LTE and 5G. So there are many ways of getting that data from the source to where it needs to be processed. And along that route, don't forget, you also have to ensure the quality of that data. And sometimes you don't want all the data. You can process it on the edge. You can essentially filter some of that out. And then there's a security wraparound as well. So the whole connectivity piece is extremely important.
So kind of complementary again to Tiago and how you get that data. So you can try to create AI, but if you don't have the basic amount of data in order to create AI, you're not going to be able to develop your AI system, and you're not going to be able to develop the use of AI in your business. So Tiago talked about Wi-Fi. then we're just going to look briefly at public mobile network, because you might say, okay, I've got a Wi-Fi network, and I do have some connectivity to a public mobile network. Well, we're going to tell you a little bit about the public mobile network and why you don't really want to rely on it for your critical business. One of the reasons is that it's not as reliable as you think. So you are not able to get the coverage in the areas that you want to get coverage. The bandwidth may vary. They may pop up in your rural neighborhood a concert, and suddenly you have very little bandwidth. The latency is what the latency is, however far it is from the core. So it could be a close core, but also be quite distant. Service levels vary. I love to give the example. I live in central London, and in my flat, I had the best signal. I had the best service. And then I got a text message saying they were upgrading. And for a week, I had no service. And then afterwards, I had poor service. Now, if I was running my business there, that would be quite impossible. And if I was relying on the data that I could get from that in order for an AI system to work and for me to run my business further, that would be quite impossible. So Martin, over to you.
So Kathy's explained a bit about a public mobile network, which we're all familiar with, and of course there are limitations in the coverage and the bandwidth, and depending on who else is on the network. So when you look at the difference between a private and a public network, it's actually quite simple in terms of illustrating it. You can see from the screen here. So what we essentially do, we take all the best attributes of a public mobile network. We take those physical components and we deploy them on site. So if you can imagine a process plant, for example, that might be over let's say a square mile. You can then imagine taking all of the network components and having complete control over them. So, looking on the left-hand side, anything from, let's take cranes for an example. You've got vehicles, you've got monitoring equipment, you've got handhelds. So typically, push-to-talk devices, tablets for mobile worker. We can put video, stream video on it. You can control drones. You can also have, assisted worker as well, using augmented reality, to assist using, people remotely to help people in the field, to diagnose faults and ensure operations. The network equipment itself is the same as the network equipment you'll get on a public network. The radio is the same. They come from the same manufacturers. But very importantly, the core, so the network core, if you like, to imagine the network core, if you can imagine the network components being like, your PC hardware, your motherboard, the fans, the power supply. The network core really is the operating system. It's like Microsoft Windows or iOS. That can remain on site as well. So what that means is you get complete security of your data. So in some scenarios, we can design these so that the data never actually leaves site. That gives you arguably the best security that you can get. So the best attributes of a network are you get your bandwidth, high bandwidth, low latency, which is very important for a lot of applications. Your security I've mentioned. The availability of the network is very high. A lot of the time we're talking about 5 nines availability, which also means it's highly reliable. And the high performance core is something which brings a lot of benefits over having to send the data out into the outside world, which could be hundreds of miles away, to be processed. And obviously the upkeep of the network via the core functions can be kept on site. And the other point we should make here is this is licensed spectrum. So a lot of the alternative technologies that we consider, Wi-Fi, Bluetooth, Zigbee, a lot of the other technologies, they work on open spectrum, which is great because you get a lot of a variety of equipment and manufacturers. However, they do have the drawbacks. And when you have licensed spectrum, that particular utilization of the spectrum is for you as the owner and operator of the private network. And with licensed spectrum, you're allowed to use higher power. And the higher power, obviously, it goes further. So we often find with private networks, we've got indoor coverage, but also the outdoor coverage over those square mile sites is very important. So I think we'll take those one by one. I'll start off with improving safety. So, for example, you know, when you can track assets using private networks, you've got the opportunity to know where people and machines and plant is all the time. So, for example, if you have workers, you know the location. If you're aware of a location on the plant which is hazardous or dangerous, using the network and using AI systems, you can actually process that data and provide meaningful information. Catherine, did you want to talk about remote operations?
Yes, so about remote operations. So what we mean by remote operations is everything from being able to remotely control either a vehicle or a crane, or being able to remotely see what's going on site. So with the information that can be gleaned from the high availability private network, whether it's 4G or 5G, it's easier to control the remote operations. And also with regard to something like maybe remote control of a key crane or a crane, the bandwidth that you can get through there and also the lower latency enable those things to work.
Great, thanks. And predictive maintenance is the next one. So I think when we look at the the end-to-end solution here, let's imagine an asset, and if you've got a process plant, a typical asset could be a heat exchanger. Now, if you're monitoring every data point in that heat exchanger, you can process the data using edge, mobile edge, or you can process it in the cloud. What it allows you to do is to actually have a picture, have a real image, even a digital twin of some of these assets. And you can actually start to look at characteristics which would infer there's likely to be a failure. So your maintenance routines, you can actually spend less money on maintenance and use AI to process the data to predict when an event might happen. And if you're collecting data from a number of assets, not only on one site, but potentially across the world. So for example, if you're a manufacturer and you're able to correlate, failures with certain occurrences and events, they might be mechanical or electrical, they might be process driven. You can build up a very rich sort of picture of these. It enables you ultimately process the operations are far more, if you like, the whole thing's more productive. You're losing less time, there's less downtime because of unexpected failures.
So group communications is another great way to use a private network. And as you know, most group communications today are something like Tetra. Well, this would be using essentially push to talk over LTE. What that enables someone to do is to get connectivity wherever they need to get connectivity, again, in the private network. And it's also able to use voice and video, as well as other data services, in order to communicate about safety issues, to show what's going on in a certain area to a team member who's remotely located. And it is super reliable.
And the next one is process monitoring. So conventionally, when you look at the communication protocols that have been used, HART, for example, using 4 to 20 milliamps is popular in process. Then they have Foundation Fieldbus, which is sometimes used, and now it's gone on to some wireless protocols, wireless HART and some of the others. What you're measuring is usually pressure, temperature, level, flow, those sorts of tags, if you like. In terms of the 5G network and the private network, and this could be LTE or 5G, there's plenty of bandwidth and plenty of scope to take a lot of those measurement points and actually process them, via either cloud computing or on site using AI and machine learning. There's a great opportunity here for companies to actually develop algorithms, to develop sort of AI around looking at, process optimization, which doesn't need to be done in the conventional sense using a DCS. So we're seeing a lot of interest around process monitoring.
Absolutely. And finally, site security. And site security can be achieved through connectivity from anything from IoT around the site to cameras around the site to those drones, actually beyond visual line of sight drones, going around the site and looking for differences in what's going on site. It also harkens back to that improving safety, where a camera or a drone going around can actually look and see what's different from the last time it's made a sweep of the area and notify the operations staff to make a change or to take action.
Thanks. So I think we look at commonality of why private networks here. A lot of these applications, a lot of these use cases are based over sort of wide areas in challenging environments. So where you need the signal quality, the signal strength, the reach of that network, if you look at each and every one of these images, there's a lot of steel, there's a lot of concrete, there's a lot of moving parts. Where you need mobility and penetration of signal, this is really where, private cellular networks come into play. And this is a slide we've done several times before, and I thought we'd use it just because to have a look at how relevant AI is to to this whole game. Industrial IoT, predictive maintenance I spoke about earlier. Using algorithms, building up those rich data sets for prediction, remote asset management. Using AI, using machine learning. So I think everything here is so intertwined. There's when you look at all the different technologies, and Tiago spoke about wireless, and there's definitely a place for Wi-Fi here. Fixed wireless access is something which I think definitely works really well when we look at private networks, so we can extend the reach. That last few feet or last short distance can be done using Wi-Fi. So I think that picture sort of sums up. I think we're at the end of what we wanted to present. The last slide is probably just a contact for Catherine and I, but we're happy to take a few questions if any of them have come in.
Yeah, thank you very much. Thanks, Martin. Thanks, Catherine. So we've got a question here from Alex. Have you experienced challenges between private 5G and public network interactions? And there's a second question there as well from Alex. Is your spectrum reserved for N77 or other bands in the UK?
So we don't have spectrum in the UK. So we use the shared access spectrum of N77, which is 38-42. And we also have the option of using a sort of borrowed from mobile operator spectrum in 4G. And it's something that you get through Ofcom. If the mobile operator is not using it, we can make a petition for it. So that's what we use. And the first question, has there been any interference? Not in my history of doing this. Have I seen any interference?
Okay.
Any other questions?
Yes, just one question, another question as well. Is a private network inherently more secure than a public network, or are they just similar levels of security, would you say?
So I guess if I had to say 3GPP equals 3GPP, then that would be equal levels of security. Where it's different in a private network is only the things and people that you authorize to use that network can use that network. So whereas in a public network, you might have a ton of people roaming from a different country onto your particular cell that you're connected to. That is not possible in a private network.
And I think I'd add to that as well. When you look at the architecture of a private network, if you have an on-premise core, we could also arguably say that all of the data, remains on site. Whereas with a public network, unquestionably, your data is going to have to leave that area to be used across the wider network, and potentially processed somewhere else using processing that could be using, having the multiple functions as well. So just the physical area of the network means it's inherently more secure.
And to add to that, one more, just thought of something else, sorry, is that the private network is essentially an extension of the LAN. So what private network doesn't, unless the company that we are working with, we don't connect the private network to the rest of the world. The company connects it to the rest of the world. So as an example, all of the protocols and rules around internet connectivity that the company has internally get cascaded into that network. One of the things when I was working with the Port of Felixstowe, they said, so we get to control whether the people in our tugs can watch Formula One or not. Absolutely.
Okay. Well, a very timely example. Okay. You're obviously a fan. I think that's all the time we have for questions. A big thank you to Martin and Catherine, and I'll just share screens so we can wrap up from today. But thank you very much, Catherine. Thanks
Thanks,
very
Mike.
much.
Great, thanks very much.
I'm going to share my screen.